The development of the Euler-Bernoulli beam equation is a story that stretches over centuries and multiple contributors. Early attempts to understand beam bending began with Leonardo da Vinci, who made important observations in the late 1400s but lacked the mathematical tools to create a theory. Galileo Galilei also worked on the strength of beams in the 1600s, though he made some incorrect assumptions about the position of the neutral axis in bent beams. Jacob Bernoulli advanced the mathematical description of beam bending in the late 17th and early 18th centuries, using the newly developed calculus. He described the deflection of cantilever beams and introduced basic equations linking curvature, load, and material stiffness. Daniel Bernoulli, Jacob's nephew, later expressed the strain energy in bending and considered small deflections and linear elasticity. In the mid-18th century, Leonhard Euler and Daniel Bernoulli combined and extended these insights to derive the full differential equation relating a beam's deflection to its applied load and material properties, the foundation of the modern Euler-Bernoulli beam theory. This equation describes how beams bend under transverse loads and is based on the assumptions that materials are linear elastic, obey Hooke's law, and that cross-sections remain plane and perpendicular to the neutral axis after bending. Although the Euler-Bernoulli theory was formulated around 1750, it was not widely adopted by practicing engineers until impressive structures like the Eiffel Tower and the Ferris wheel in the late 19th century demonstrated its practical validity. Since then, it has become an essential tool in structural and mechanical engineering, forming the classroom cornerstone for designing and analyzing beams, bridges, and frames.